In this video, what I'm going to do, I'm going to show you some applications that we use with arrays. So the first thing I'm going to do, I am going to create an array, and I'm going to assign 1,000 values of this. The size of this array, is going to be 1,000, and I'm going to randomly assign values to those 1,000 elements in a range from 1 to from 0 to 100. So let's start with 1 all the way to 100. So what do I do here? Basically, let's go ahead and create a final integer size equal, that's 10,000. It's going to be 1,000. Now I'm going to create an array. I'm going to type up an integer, and I will call it stat equal new integer, and I'll go with size. Again, since size is a final, so let's go ahead and capitalize it. Size. And put semicolon here. I need to go for a for loop, and in this for loop, I'm going to go through all these elements. Integer I equals 0, I is less than size, and then I plus plus. And in this area here, I'm going to say, what did I call it? Stat of I equal. Now let's I don't know if we mentioned that before, but this is how we create random values. First of all, we need to cast it, because usually it's not an integer. Well, before we do that, let's just go ahead and talk about the function that can generate random value. Basically, we need to call the class. It's a static method that belongs to a class math, and the function itself is called rand. Now, random by itself, this function here, oops, what did I click? This function here basically is going to produce a number between 0 and 1, so it's a fraction number. What I need to do, I need to multiply that by 100. So this basically will generate a number between 0 and 99. And because I want to have because I want to have a value that starts from 1 all the way to 100, I need to increase the whole thing by 1. Plus 1. This basically will generate a random value from 1 all the way to 100. Now remember, this function here that I'm going to highlight, or this portion that I'm going to highlight by itself, is going to produce a number that has a decimal value. Since my array is a type of integer, so I'm going to cast it to an integer, and then after that I'll add 1 to it. So this basically should generate a number, an array that will this is going to create random values and assign it to my 1,000 array. Just to be sure, this is for testing, I'm just going to go ahead and show it integer x in stat. And what I'm going to do here, I'm just going to go ahead and system.out.print. And I'm just going to put x here plus a space, put a semicolon here. And then after that, let's go ahead and type system.out.print line. Now, of course, this is going to be a really, really long array. Print line. Well, let's just give this a test. Oh, this is not what I expected. Why is it doing it this way, just once? Let's see, what did I do wrong here? I think I might know what is going on here. This basically will... Let me take the integer away. And let's take the plus 1 away. Let's take this away. Now this by itself will generate that integer. What I need to do here, I need to cast this thing. So I can come here Now let's cast it. Let's give this a try now. Now he's complaining. Oh yes, this here. That was the problem. I got an extra. Now all I have to do here is say +1. Let's run it again. One of the parentheses actually led to the whole thing. And here we go. So you can see here, this is my number. I do have 100. It's really hard to scan the whole thing, but so far everything looks okay. So let me just, this is again just for testing. I'm not going to delete it, I'm just going to keep it just in case I need to do some testing later. So, first step is basically whatever I just did here. I created an array, 100,000 of the size of 1,000, and randomly assigned values in the range from 1 all the way to 100. Now, the first operation we're going to do is search. And when I search, what I'm going to do, I'm going to create a function that will do the search for me. Whenever you search for a value inside an array, there's a lot of possibilities, but let's think about them now. There's a possibility that the value you're looking for doesn't exist, or could exist, and it could exist one time or multiple times. So you need to put all these considerations in your mind when you build your function that will kind of search for it. So what I'm going to do, basically, I'm going to create an integer. I'm going to call it index. And the index here basically is going to equal the location of the value that I'm searching for. So I'm going to create a function called search. And I am going to pass the array. Let's go ahead and pass the array, which is STAT. I'm going to pass the value I'm looking for. For example, I'm looking for 87. Semicolon. Now, of course, he's complaining search doesn't exist. So what I need to do, I need to go ahead and create that function. And that's what I'm going to do here. So it's basically public static integer search. And in this area here, I am going to pass the integer array of integers, I'll call it S, and I'm going to pass an integer for the index that I'm looking for. Well, you know what? Yeah, val that I'm looking for. Now, let's just think about this again. I'm passing the array, I'm passing the value that I'm looking for. There's a possibility that the value I'm looking for do not exist in this array, or it does exist one time or multiple times. For me, all I care about if it does exist, and if it does exist, I want to know where does it exist the first time. I don't care about the second or third or the fourth time that value does exist. So how do we do that? Well, the idea is very simple. First of all, I'm going to come here and create an integer. I'll call it index. And I'm going to assign the value -1 to that index. Now, why -1? I'll explain that in a sec. But index by itself will hold the value that the index or the location of the value I'm looking for. And here, what I'm going to say, return index. So here's what I'm going to do. I'm going to come here and say for. I can go with the smart loop here, integer x, and I'll put s here. And inside this area here, what I'm going to do, I'm going to go, well, actually, this is not going to work. My bad. I need to have access to those indexes. So integer I equals 0, I is less than, well, I need the size here. So let's go ahead. I know the size is 1,000, but I cannot use it here because this is a local variable. So I need to pass size as well. And here I need to come here and type integer size. So I'll come here and type size, and then I++. So I'm going to go through all these elements. What I'm going to do here, and this is very important, if, and this is very important, as I said, s of I does equal the val that I'm looking for. That basically means I found it. Not necessarily the first one, of course. I'm going to check the first one, the second one, the third one, I'm going to scan the whole 1,000 elements. And the moment you found the value, a match for the one that you're looking for, this is what you need to do. You need to come here and say index equal I, because you found it. And then after that, you have to break. Break basically means leave. This for loop. So after this for loop, you get to this condition. If this condition becomes true, you found the value of the code. Break. That basically means skip everything here and go to the index and return index. So let's just look at the values here. Imagine I'm looking for the value 73, the one that I highlighted. So I am going to compare 73 with 65, no match, no match, no match, no match, no match. Oh, here's a match. Where is that match found? It's basically found at 0, 1, 2, 3, 4, 5. So index is going to be updated to equal 5, and then I'm going to leave this for loop, and then after that I'm going to return index, which will represent the position or the location of the value that I'm looking for. Now, what if the value that I'm looking for doesn't exist in this list? Basically, index will never be updated and will hold the value of -1, and I'm going to use the value of -1 as an indication that the value I'm looking for do not exist or doesn't exist. Now, look at this value here, 73. I do have another 73, but again, when you find the first match, you break. That basically means you're going to stop searching. What if I take the break away? Well, if you take the break away, you find a match, you update it, and then you find another match, and then you update the index, and you keep going until you're done. So basically, if I'm looking for the first appearance of the value, 73, I need to have a break here. If I'm looking for the last appearance of the 73, I need to take this one away, or I can reverse the search from the back of the array all the way to the front of it. Anyway, this function here will search for a value inside an array that has a size. Now, what I need to do after I come here, I need to check and say if index equal -1, I'm just going to have to say system.out.print line, and I'll just say value doesn't exist. And then here I'll tap else. Well, if actually it wasn't -1, then it does exist. And all I have to do here say is value exists at index, and you put a plus index. And here we go. So what I'm going to do, I am going to search for 87. It should. I got 1,000 values, so it should does exist. And it does exist at that value. Let's put 100. And 16. Now the final value I'm going to put 110, which I know it doesn't exist because we just said it should not. And here it is. Value doesn't exist. So as you can see here, this function worked perfectly with no problems. Now that we're done with the search algorithm, let's go ahead and keep going with the rest of them. Search method. Let's go ahead and continue with the other methods. Mini and max are very similar, so I am going to go ahead and copy this and modify a little bit. So first of all, I need to change the name, mini. It's going to return an integer, which is basically the index of the smallest value. I'm going to pass the array, I'm going to pass the size, and there's no need to pass a value. I'm not searching for anything. There's no need for this index as well. And I'm going to return a value. So how do I find the minimum value? Well, let's just take all this away. Let me take this away. Okay, so here we go. This is the mini function. First of all, what I'm going to do, I am going to assume that the first value is the minimum value. So integer mini val equal s of 0. That's my assumption. And then what I'm going to do, I'm going to start counting from 1 instead of 0. And you know what? Instead of 0, let me just replace that with, I'm going to assume that the mini index is the first one, which equals 0. And I'm going to use mini index here instead of the 0. Now, what I'm going to do, I'm going to return mini index. Okay, we'll talk about this in a sec. Now, all I have to do now is to compare, go through the elements of the array starting from the first one, since I'm using the first one here. So starting from the second one, sorry. And then all I'm going to have to do, I'm going to compare each value with this mini value. If it happens that I found a smallest value, I'm just going to swap it, change those two values to the new value. So for example, let's say the first value was 100. No, sorry, 50. And then the second value was 90. So the 90 is not less than 50. But the third value was, let's say, 20. Oh, now 20 is less than 50. So all I have to do is basically to update the mini value and the mini index. And then keep going through the whole array looking for the smallest value. So well, I'm going to come here and say if what? If the current value that I have here was less, remember it has to be less, I don't care about equal, less than the mini val. So if it happens that the current value that I'm scanning is actually less than this one, then all I have to do is to update the mini val to equal s of I. And then after that, I need to also mini index to equal I. Why you didn't like it because the I? Okay. Now, this will guarantee that I will look for the smallest. This basically at the beginning I said I'm going to assume that the first element is the smallest value. And then after that, I'm going to scan the whole array. Every time you find a value that's smaller than the current value, then you're just going to have to update the minimum value and update the mini index. And you're going to keep going through the whole array until you find the smallest value. Now, if I want to come here, I'll just go here, system.out.print line. Let's just put a message here. Mini val is, well, mini value is, and just call that function. What did I call it? I called it min. Well, let's go ahead with that name. Min, pass the st8, and pass the size. Oh, did I use the size here? Yes, I used the size. Okay, let's give this a try. Oops, he doesn't like semicolon. Oh, the minimum value, that makes a lot of sense. It's 1. Now, if you want to know where's that mini value, all you have to do is just to search for it if you want to know what is the minimum value. Now, since this is a random value that's going to be generated, the max I can guarantee the max is going to be 100. Well, let's go ahead and do that as well. So if I want to find the max, look what I'm going to do. This is very, very similar. Just copy this. Again, this is a function I'm building. Instead of mini, let's call it max. Now, instead of mini, let's call it max and max. And then here, max and max again and max again. Now, the only different change that I need to apply here is basically this value, this operation. Instead of less than, make it greater than, and of course max here again. So that's basically how I'm going to calculate the max. Again, I'm going to assume that the first element is the greatest value, and then after that, I am going to look and see if for the rest of the elements, if there's any value greater than that one. So let me just copy this and put it here, and I can guarantee max is going to be 100. Let me just run it. I didn't run, I just saved it, sorry. And here, oh, actually it's 42. That's weird. Let's try again. How is that possible? The mini value, oh, this is max. Let's just put max again here. Well, there's something fishy about this. Number one, max value could never be. Oh, no, 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 no. Look, I made a mistake with both of them. Instead of, I don't care about the index, I care about the value. I'm supposed to return mini val. Mini val. And here, max val. Let's run it again. And you'll see that, yep, 1 in 10. And I can guarantee if you run it multiple times, you're always going to get the same. Now, what I'm going to do, just to make sure, if I reduce the size here to be 10 instead of 100, you'll notice that my chances of getting those two values, see, 6 and 40, 94. 1 and 79. 1 and 90. 11 and 88. Okay, let's go back and put this as 1,000. So this is mini, this is max. Now let's calculate the sum and the average. Well, you know, I'm not going to create a function for that. I'm just going to go ahead and do them here. How do I find the summation of all these thousands of values? So I need to create an integer called sum. And let's set sum to equal 0. Now, I need to have a for loop that will iterate through all the data. Integer I equals 0. I is less than size, and then I plus plus. Now all I have to do here is come sum plus equal stat of I, semicolon. This basically will calculate the summation of all the values of the array. I'm going to assume that the summation variable equals 0, and I'm going to go through all the values, and all I'm going to do, take that 0, add the first element to it, and then take whatever the results and add the second element to it. Now I got the first element plus the second element stored in sum. After that, I go to the third element and add it to the summation of the first and the second, and keep going that way until you're done with all of them. If I want to see here, let's copy this. I'm going to put it here. And I'm going to say sum, and I'm just going to come here and type sum. That's the value I'm looking for. Now that would be a really big value. Now if I want to calculate the average, and this is a place where a lot of people make mistakes. Average. Now look what I'm going to do here. If I come here and type sum divided by size, and that's basically how I calculate the average, the summation of the values divided by the size. But remember, size is an integer and sum is an integer by itself. So I'm dividing integer by integer, so the average is going to be an integer, but again, it should not be an integer. So what I'm going to do, I'm going to cast the sum. So the whole thing here need to have parentheses. This basically, this by itself will convert the sum to a double, so I can actually perform the operation. Now let's run it, and you'll see that here we go. Okay, why is the average a number with no decimal points? Oh, because this is an integer. I'm supposed to convert it to a double. My bad. And here we go. Now, if you just think about it, this is the sum. If you divide that by 1,000, that's what you're going to get, which basically makes a lot of sense. And here we go. And keep going. So, as you can see here, the value, it's always in the range of, the average is in the range of 50. Anyway, let's go back here and talk about the standard deviation. Now, this is a statistic concept. Now, whenever you have a group of data, usually what we like to do, we like to know how far the values that we have from the average. And let me just show you some graphs to explain that concept. So, standard deviation. Of course, there's a lot of, and let's go and look at some images. And here we go. If you have a data and you calculate the standard deviation and you found the value is big, that basically means most of the values are very close to the average. But if you have a value that's basically the standard deviation is big, that basically means the values are actually a little bit far away from the average. This here, let me see if I have multiple here. This graph here shows you an example. Oh, sorry, this is a small standard deviation. This is a high standard deviation. I just switched the concept. So whenever the standard deviation is small, that basically means all the values are closer to the center, which basically represents the average value. And whenever the standard deviation is large or big, that basically means the values are going to be a little bit far away from the from the average. So what I want to do here, I want to go ahead and figure out what is the standard deviation of those 1,000 random values that I created. And this here represents the equation that we use. Well, we have the number here. What you have to do, basically, you take every single value, you subtract from the average, and you took the power of that value, and you do the summation of all the values. So we need to actually perform this calculation here first, and then you divide it by, and then you take the square root of it. So I need to take every single value from that array and subtract it from the standard deviation, and then calculate the power of 2 to it. Let's go ahead and do that. What I'm going to go S standard deviation, SD. And I'm going to call this a double equal double stash, and I don't have to assign it to anything. Now, as I said, I need to have a for loop. So let's go ahead and create a for loop. And this for loop, what I'm going to do, I am also going to need the sum again, but I'm going to create a new sum. So let's go ahead and do integer. Well, yeah, integer should be enough, but let's go with doubles. New sum. Set that to 0. Let's put a W here. So I'm going to use this new sum here. Now, oops, let's copy this again, Control C. New sum plus equal. Now, in this area, what I need to do, I need to subtract stat of I minus the average that I calculate. Oh, did I calculate the average at all here? No, I didn't. Well, this is where I made a mistake, so let me just cut this part. Now I'm going to come here and type double average equal that value. Put a semicolon here. And let's copy the average and put it here. Because I need the average in the calculation coming here, so I need to have it here. So I'll just put it in this area. Now, this has to be to the power of 2. Now, again, this is not how it works in Java. So what I do, I have a function called power. I can say POW. I think I have to type math. Oops, let's go back. Math dot power. And let's open it here and put 2 here. Semicolon. And here, that works. So I am going to calculate this, subtract the average from each of those values, and then do the power of 2 to it, and whatever the value is going to have here is going to be added to this value. Now that I'm done with that, I can come down here and say SD equal math dot sqrt, that's square root, and then I just have to put the new sum divided by size. Now let's just think about that. Since this is a double, then there's no problem here. I'm not dividing it by integer. That should be enough. Now let's run it and see what's going to happen. Of course, I forgot that I have to print the standard deviation. So let me just copy this, put it down here, and let's go Here's the standard deviation, so I'm not going to make any spelling mistakes. Oops. And put SD here. Now this is the standard deviation. Now I am wondering if, let's keep going, run it again, run it again, run it again. You can see that the values are between 28 and 29. I am not sure if the standard deviation will have a value this big. Should it be? Let me just go back to the standard deviation and have a look here. So this is the population standard deviation, n is the size of the population, x is the value for a population, u is the mean. Yeah, mean is the average. So yeah, it looks like I got everything right. Let me just values table. I just want to make sure that the range that I'm getting is not. How to estimate the standard deviation? Range values. Oh, here it is. Max value minus minimum divided by 4. So this is usually what the standard deviation will be like. So for those array of values, standard deviation basically would be 3.5. So yeah, that makes sense to have that value. Okay, I just thought that standard deviation usually it's less than 1, but it's not the case. Let me just go back and make sure that I'm not making any assumptions here. Standard deviation, mean, this is just an example. This is the square root divided it by the nearest 147. Yeah, so it could be a value that's greater than that value. Anyway, let's stop at this point. Let's go back to the Eclipse. And here in this area, as I showed you before, all I did is basically I did the calculation problem. So I'll see you guys later.